Rate.
Rate. Excellent.
Where is the word rate?
The word rate. The word rate tells us it's a derivative.
I don't think it's going to survive much.
At the instant when the radius is 4 centimeters, we want to know what the rate of change of the radius. So that's another rate.
We're doing 2 rates?
Well, one's we're finding, one we have.
Whoa.
Okay, so first let's talk about all the variables that are in this problem.
Pi.
No, pi is not a variable. It's just
R.
letters. R, we have a radius. So R. There's one more.
V.
What is it?
V.
V.
Sure.
Ah, she said D.
Yes, she did. I was like, okay, yeah, I said that. Well, that's like the thing we're equaling. I don't think that counted.
Well, it is a variable though that we're given. Yes, we're looking for it, but it's still a variable. V is a variable that we're using here, and R is a variable. Those are only 2 variables.
Yeah.
Now, number 2 says identify which, if any, of the variables in the problem that remain constant.
None of them.
Yes, you are absolutely right.
No, because we're never None.
Now, the reason why it's none of them is because this is
It's
shrinking. So the radius is not going to be the same. Now, a good example of things that do stay the same, we'll probably have this problem in a minute, but if you have a ladder, like a ladder is a certain amount of feet long. That's a constant.
But, like, can't you shrink it?
Yes, you do have, but say it's to its smallest height.
Yeah.
That ladder then would be constant.
Or a dark edition.
Can't I move?
Oh my gosh, if it was a ladder that could not. If it isn't one that goes up and down. If it's like a step ladder.
Like a normal ladder that doesn't move because if the ladder moves, it'll fall.
Well, like, you have to, like,
No,
walk in.
more of a ladder that's wobbly. You know what I'm saying?
Okay,
And if it moves,
identify the rates that are given and the rate you wish to find.
The rate we got was 235.
230.
Okay, so dV
Oh, I thought you said 230.
dt is 230. Actually, close. I'm missing something here.
D
4
pi.
over 3? I don't know.
Yeah.
No, missing something still.
4.
D pi dt.
You're still missing something?
Yeah, from this rate, I'm missing something.
Not d pi dt. How do we do that? Is it
Negative.
There you go.
Oh.
Thanks, Faith.
You're welcome.
How do I know it's negative?
Because
It's
it's
decreasing.
decreasing.
It's decreasing, yeah, leaking
You
out.
got that.
Okay, what's the rate we're trying to find?
So raise 4. I don't know.
The rate of the radius. How would I write that?
d r dt
Yes.
is equal to
We don't know.
question mark.
And what would the
Negative
unit?
question mark.
Well, we don't know if it's positive or negative.
Well, but
Wait,
it's still
couldn't we-
decreasing.
Yeah,
no, we
true.
stopped it at
Oh,
4,
we
didn't
don't have
we?
a problem.
No.
with
When we
that.
stopped the radius, but not the rate. Anyways, what are the units?
Centimeter cubed per
Centimeter. Okay.
Is it cute?
second squared.
I don't know.
Centimeter.
Yeah, you wrote cubed on the first one.
Okay, I wrote
No.
cubed on the first one. It was given to
It'd be
us, but it's volume, right?
Yeah.
Volume is always cubic, whatever.
Yeah.
Which one's always squared?
Area.
Area. And then this is not an area. This is a radius. So when you measure a
It's flat.
radius, it's just what?
Flat.
Flat,
Just
yeah.
one.
So it's just centimeters over minutes.
Was it minutes? Yep.
Yeah. Yeah.
Yeah.
I said that weird, but, like, I think I've been.
Okay, number 4.
Right, an equation.
Write an equation, often a geometric formula or trig equation that relates
Oh,
all of the variables in this problem for which a rate is given and for which a rate is to be determined. Substitute any value that represents a variable that is constant throughout the problem. It is important to keep in mind that you can have only one more variable than you have rates. You may have to make a substitution that relates one variable in terms of another. We're not going to start off with something that hard. So what's our formula that we would use?
V equals 4/3 pi radians squared.
How did you what?
What?
Is it square or is it cube?
What?
There it is.
Where'd you get all that?
From the page we just did.
That's
The
right.
last one?
Yeah.
Now, I will say this. On a test, you do not have to have these memorized. The only ones you really have to know are like, regular, like Pythagorean theorem
Is
or,
our next test open or like calculator or no calculator?
I don't know. We'll talk about it. What is
You
it?
said
First lesson.
calculator last week.
Oh, yeah, it's up there. Whatever it is. It's calculator,
My
something.
calculator up there so she can't take your mind.
Okay. So then, because I can't erase it.
That's not going to be our last test.
So like the area, you need to know that. Circumference, you need to know that. The things that are common knowledge should
How do you
be.
spell calculator?
Yes.
Aren't you in the
Yeah.
spelling bee?
So, but things that you would not, like volume of a cone, volume of a cylinder, volume of a sphere, all of those on the AP exam are given to you.
Woo.
So,
Will you give it to us then?
that's what I just was going through, by the way.
Sorry.
You don't have to do
I always
everything
try to
with the
spell
calculator, okay?
Okay, the next thing. Implicitly differentiate both sides of the equation with respect to time.
DV.
So dv dt,
Hold on. You might have the answer already.
we do
Pi
I'm looking for it.
4 pi
squared.
Yeah.
r
4
squared.
DRT.
D R D.
We did it.
You just let me go through the whole thing.
Just to take it.
Jumped in at the end. Just stole my thunder. So
Tough.
Okay.
Daniel, I don't think anyone can steal your thunder. Like, you just kind of.
So now we plug in the things we know.
yeah.
Mmm.
Sorry, that's hot.
Mmm. dv dt?
Negative 230 pi centimeters cubed.
Oh, is it just 235? It's not over anything?
No.
Okay, I'm not going to put the units on here because as math people,
We're
and
lazy.
Mr. or should I call him Coach Fong is going to hate this, but us math people put the units on at the end. I know he wants the units all the way through, probably.
I don't.
Not me.
That's maybe why I don't pass very well.
Okay,
He's
so
not
then
in
we
here
have
calculating it.
4
Zero.
pi,
4 squared.
r is 4,
Dear Lord.
and dr dt is what we're looking for.
Yes.
Yes.
There's not enough squares.
I'm going to keep going. Okay, so then we have negative 2/3, because sometimes there's more to do,
Oh,
equals 64 pi,
4.
4 squared times 4. dr dt.
Pies are gonna cancel.
Uh-huh.
Woo! Wow.
Divide by 64 pi,
Ew.
You get negative something.
dr dt equals negative 230 over 64.
Isn't,
That'll reduce.
I was like,
I know 2 will go into it.
is anyone gonna
What do you
get a
15
calculator?
over 32 though?
And that's centimeters per minute, right?
Yes.
That's what we had figured out at the
Why did
beginning.
I write that backwards? 23.
So that's the rate at which the radius is shrinking.
So it's.
I don't know what that is either.
Now you can probably go back and do the Bella.
I didn't get it.
Maybe.
you wanted to?
No,
Could you
Yeah.
assign
it won't
it
let
again?
you resubmit.
Dang.
But that's okay. Like I said,
I tried really hard.
I'll do it again.
You really did.
Okay, here we go. Next one. A stone is dropped in a calm body of water.
Radius.
And ripples form in concentric circles. We know what that looks like. You know, you got the circles that come out, yeah.
Ripple effect.
Yes. The radius of the outer ripple,
The very last one.
the very last one,
This one.
is increasing at a rate of 1 foot per second.
Oh.
Whoa.
Whoa. So, when the radius is 4 feet, at what rate is the total area of the disturbed water changing?
R.
Okay, so first, let's talk about this one.
DRDT.
Yes, I know that's got to be, it's the rate of the radius, so it's dr dt. Radius is 4 feet, and we're trying to find the rate of the total area of the disturbed
Okay,
water.
DTA over DT.
Yes, that's right. It's going to be dA over dt.
this one.
You don't have to put TA. It's just the area. Okay, so what are the variables? R
An A.
for radius and A. Very good.
A for what?
Area.
Identify which, if any, of the variables in the problem are constant.
Area.
No.
Is area constant?
No.
No, because
I said
it's getting bigger. What about the radius?
No, it's increasing.
So none.
Good job, Steve.
None.
Okay, let's talk about the rates. dr dt.
Is equal to 1 foot per second.
And what's the other one?
We don't know.
DTA over DT is equal to
dA dt equals, we don't know. What would the units be?
Feet squared.
Feet
Squared.
Because it's area.
Because it's area. Area is cubic, or not cubic, squared.
Cubic, yes.
So we're going to write an equation. What's an equation of this?
A equals pi radians squared.
Yeah. Not radians. Radius?
Radius, whatever.
Radians.
Same word.
I know. Not at all.
Potato, potato.
So, pi r squared. Yeah. We're talking about a circle. And that circle is getting bigger at a rate of the radius at 1 foot per second. Okay, so let's differentiate with respect to time. So,
DADT
Oh, crap.
dA dt
equals 2 pi R.
2 pi r
DRDT.
dr dt.
Let's go.
We did it.
Substituting stuff. Oh, you can finish this problem. You can probably start on the homework too, folks. Yes, we have to.
There's so much left though.
Really?
Yeah.
There's like
so
3
bad.
pages left.
You can still start.
I only did 1.5.
We'll finish it tomorrow.
What?
If not, I'll say you're finished anyways.
What? What's happening?
What? What?
Wow, guys, it's almost Wednesday.
Doing good, Steve.
I count down the days to Wednesday now.
I love going to school for 4 days. If I go 5, I'm gonna die.
Doing good, Steve.
It's like odd though. I wish it would have been like a 4-day weekend instead of like a half day in the middle of the day. But I don't care no matter what.
I appreciate the breaking to keep it forever now.